Bismillahirrahmanirrahim. In this session, we'll discuss some practical work on page 130 from the Tom Decken and Heather Kennett book of O-level and IGCSE physics. And here we have a ripple tank, and in this ripple tank we should wear eye protection. So eye protection is mandatory because we are dealing with this experimental setup, and in this ripple tank the behavior of the water waves can be studied. So it consists of a transparent tray containing water. This transparent wave, transparent tray, and in which we have a water, and having a light source above. From here we have a light source and a screen below, and there we have a screen at the bottom. From this light we pass through this, and this is a disturbance generator or a ripple generator. So this motor will move and it will slide up and down, and this way waves will be produced in this ripple tank. The pulses, the burst of ripples are obtained by dipping a finger in the water by circular ripples or by a ruler for a stipple. So this is a ruler, so straight ripples will be created, but with a pointed finger, a circular ripples will be generated. A bar gives straight ripples, it is just touches the water, or circular ripples if it is raised and has a small ball fitted to it. If we replace this with a small ball and we just dip it, it will create circular ripples. So continuous ripples are studied more easily if they are apparently stopped, frozen by viewing the screen through a disc with equally spaced slit, which can be spun by hand or stroboscope. Stroboscope is a device which is used to measure this kind of things, speed. So if a stroboscope speed and this speed becomes same, then it shows a still picture. So this is very important. Stroboscope are often used in a rotating devices for speed measurement or its shapes or its waves produced. So this is very important device. If the disk speed is such that the waves have advanced one wavelength each time a slit passes our eyes, they appear at rest. Sketch the appearance of the continuous ripples produced by the straight bars. What is the wavelength of the ripples? So from this experimental setup we will see all the describings of waves, such as wavelength, frequency, speed of the wave, phases of the wave, and speed of the wave. So all these will be done. So for example, if we have this kind of results obtained, which is shown in a test yourself on page 130 from the same book, the line in figure 3.16 are crust of straight ripples. So this is straight ripples, and these lines are showing the crust points. So that are the crust points, these points. So we have drawn this bars here and like this. So a few time ago this A was here and it passes and it reaches this point. So this is 5 centimeter, and from this crust to this one, from this crust to this 2, from this crust to this 3, this crust to this 4, from this crust to this 5. So this is showing basically the 5 wavelength. So what is the wavelength of this ripple? Because everything is crust, from this crust to this one crust to one crust is one wavelength, one wavelength, one wavelength, one wavelength, one wavelength. So one wavelength, but 2 wavelength, 3 wavelength, 4 wavelength, and 5 wavelength. Total wavelengths are 5. So the wavelength of the ripples is so 5 centimeter is 5 wavelengths, so one wavelength is 1 centimeter, which is very easy. In a part B, if 5 seconds ago ripple A, this ripple A occupied the position now occupied by the ripple f. So 5 seconds ago this point was here. So what is the frequency of the ripple? So this is taking 5 seconds to move from this to this. So the time is 5 seconds, and from here to here it takes 1 second, from here to 1 second, to here to here 1 second, 1 second, 1 second. So this is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, total 5 seconds. So the frequency is basically one wave in 1 second. So the frequency is 1 hertz. So this is simple. And I've demonstrated it everything, because this bar is this, and the crust is this point. So you draw this, and we can easily understand that the frequency is, because one wavelength in 1 second, so that frequency is 1 second per second, or 1 hertz. What is the speed of the ripple? So speed of the ripple is frequency into lambda. So frequency is 1 hertz, lambda is 1 centimeter, so 1 centimeter per second is the speed of the ripple. The speed of the ripple is 1 centimeters per second, 5 centimeters in 5 seconds. So 5 centimeters in 5 seconds. So it will travel 5 centimeters per second. So this is very important question, and this is the experimental setup. From this experimental setup, this kind of waves or this kind of problems can be generated and can be analyzed. So in the next session, we will discuss wave fronts and rays.